Now we will discuss about, just we have discussed about what? Inner product space and norm. This is the norm induced by the matrix. This is the norm induced by the matrix. We have just know about what is the norm, because in the function of several variables we need these things. Because what do you mean by the function of several variables? We will discuss detail about the function of several variables in the next video or next topic. But here we have to discuss about the basic things related to the study of the function of several variables. Function of several. Now we will going to define or discuss some definitions in order to study the function of several variables. So what is meant by the diameter? What is the diameter? Diameter of a circle. It is the maximum distance between 2 points of a circle. Isn't it? So here also same definition. The maximum for and this is the diameter for any set. For any set A. What is the diameter? If suppose this is a circle. If this is a circle, then what is the diameter? Diameter is nothing but maximum distance between the 2 points. Similarly, let capital A be a non-empty set. Be a non-empty set, then this is the notation for diameter of A, and defined as diameter of A is equal to what? Maximum distance, supremum of distances between x comma y, where x comma y belongs to capital A. What is the diameter? Diameter is the supremum of distances, and distances taken over this set A. These are the distances taken over this set A. So this is nothing but diameter is what? Distance, maximum distance between 2 points of a set. So this is the definition of diameter. Next definition, distance between two sets. So how we will define distance between two sets? Let capital A comma B are subsets of x. Let capital A comma B are subsets of x. Then distance between the two sets A comma B is, here we will take infimum, minimum distance between these 2 points x y, where x belongs to one set and y belongs to the another set. That is, suppose these are the two sets. Suppose this is set A, this is set B. Then there are several distances between these 2 points, isn't it? But among these distances, whichever the minimum, suppose this distance is what? Minimum distance between among all the distances. Then this is what? Distance between these two sets A and B. Whenever there is concept of distance, we have to take the minimum one. So the distance between A and B is what? The distance between, the minimum distance between the distances of all the points of the set A and B. What is the bounded set? If diameter of the set is bounded or finite, then we say that the set is what? Bounded set. Next definition. Next definition is about what is meant by the diameter of set. Sorry, what is meant by the neighborhood of set. So these are the very important definitions in order to study the function of several variables. That is definition of neighborhood, definition of limit point, definition of open set, and definition of closed set. So first we will study what is the definition of neighborhood. neighborhood of a point. Let capital X, first we will define the neighborhood in the matrix space, then we will come to our point, that is Euclidean matrix space. Okay, so let XD be a matrix space, let XD be a matrix space, and P belongs to X, then neighborhood of point P with radius, or no need to consider the radius, neighborhood of a point P is defined as it is denoted by this notation M of P comma. Now what is R? Suppose I am considering my neighborhood, so I have the condition no, because if suppose this is my house, then okay, then these are the neighborhoods of my house, my home. But if I am considering this one, this family, so these are the neighborhoods or not? So these are also neighborhoods, but there are the limitations. No, suppose my village is, or so my home is, suppose at A place, and B place is from the distance at suppose 2 or 3 kilometers. So can we say that the people whichever will live in the B place is the neighborhood of the A place? So there is also consideration of the distance R. So there, in order to define the neighborhood, we have to consider 2 points, 2 things: the point and distance R. Then neighborhood is defined as N of P comma R is equal to the set of all the points X comma Y belongs to capital X, such that I can consider this as X. Suppose this is X is equal to X1, X2 belongs to capital X. It is defined as distance between set of all the points X. Neighborhood is what? Set of all the points which satisfies this condition X comma P is less than R. Is less than R. These are the points which satisfies this condition. Distance between these 2 points is strictly less than R, then this set is called what? Neighborhood of point P. Okay, so this is what definition of neighborhood. After defining the neighborhood, we are going to define the open set. What is the definition of open set? Let XD be a matrix space. Let XD be a matrix space, then the subset capital A of X is called open if there exists a neighborhood for each and every member of this set A. That is, if for all P belongs to A, there exists neighborhood I or N. Neighborhood N of P such that P belongs to this neighborhood and this neighborhood is subset of A. This condition gets satisfied, then we say that this set A is what? An open set. That is, every neighborhood of every point has a neighborhood in this set A. Every point for all P belongs to A, no? So every point has a neighborhood in this set A, then we say that the set A is an open set. Okay? If every point has a neighborhood every point has a neighborhood. When they set A, then this set is called as an open set. So let us discuss about some examples of open set in Euclidean metric space or n-dimensional real metric space with Euclidean distance. Let us find n of what? Suppose 0, r. So we know that this is the notation for neighborhood. We are discussing about the examples of neighborhood and open set. So this notation is nothing but what? Neighborhood of this point 0 with radius r. So it is collection of all the points x comma y with the condition d of x comma y with 0 is strictly less than r. Now here we are in the Euclidean metric space. So metric is defined like this. I will just change the notation. Suppose this is x1, x2. So d of x comma y square root of x1 minus y1 bracket square plus x2 minus y2 bracket square, where x is equal to x1 x2 and y is equal to y1 y2. Okay. Now which is equal to d of x1 comma x2 such that, now this distance is nothing but defined like this, x1 minus 0 bracket square plus x2 minus 0 bracket square is strictly less than r, which is equal to x1 minus x2 such that x1 square plus x2 square is less than r is equal to x1 comma x2 such that squaring on both sides we get x1 square plus x2 square less than r square. So these are the points x1 comma x2 which satisfies this condition, and we know that these are the interior points of the circle. Okay, these are the interior points of the circle. So these are these points. It doesn't include the boundary point. It doesn't include the boundary point. So this is an example of neighborhood. This is an example of neighborhood of this origin with radius r. We can vary the radius r is equal to 1, 2, 3, 4, 5. Okay. What do you mean? Okay. Next one. Now the open set example of, and we know that if suppose this is a neighborhood of this point O, now you can consider neighborhood as an open set, because if I am taking any point, suppose if I have taken any point of this set, suppose this point, so I can choose R such that there exists a ball, open ball, which is completely lying in this set. So every point has a neighborhood which is lies in this set, because we have to freedom to choose the R. We have to freedom to choose the R. Suppose you are given me a one point, then I have to give the R such that this open ball completely lies in this open ball. So open ball is R are the open set. Open set need not be open ball, but every open ball is an open set. So this is also example of a open set also. So there are some examples: x comma y such that x plus y such that x into y is less than 0. This is what? Product is negative, so one of them must be negative. So here y negative and here x negative. So x into y is not equal to 0, but product is negative. So this region, and here this region also, this region. So except x-axis and y-axis, except this x-axis, sorry, this x-axis and y-axis, all the regions, and this is an open, because whatever you point given, suppose you had given the point like this. Suppose this is the point x and y, and we have to draw the open ball. Now here this distance is what? Y. This distance is what? X. And you have to draw the ball. Okay. I will consider suppose this point here, x and y. This distance is what? Y distance. This distance is what? X distance. And I have to draw the ball such that it is completely lies in this region. So how we will choose the R? Choose R is equal to minimum of x comma y. So minimum of x comma y is this, and now draw the ball with radius, with this point x comma y with radius r by 2. So this distance, and if I draw this ball which is completely lies in this set. Okay, so for every point we can apply the same procedure. Draw the open ball which is completely lies in this region. So this is what? An open set. But this is not an open ball. This is not an open ball. So there are some examples of the open ball. These two are same. X plus y is strictly less than 0. X not equal to 0. Y not equal. Okay. You can input the conditions such that, and you can check easily check there. These are the open sets. Okay. With this, we will cover the definition of open ball, open set, matrix space, Euclidean space, neighborhood. So in the next lecture, we will discuss about the limit point, closed set, closed ball, and we will further discuss on the sequence or sequences in RL. Okay. So in this next video, we will discuss all these things. So thank you. We will conclude here.